All right, today we're talking about real numbers. It's lesson 1.3, and you guys need to know all of these different sets. Natural numbers, also known as the counting numbers, 1, 2, 3, 4, 5, etc. These dots mean it goes on forever and ever. Whole numbers are the counting numbers and 0. Integers, all the negatives and positives, but no decimals or fractions. Rational numbers, any number that can be written as a fraction. Irrational numbers, a number that cannot be written as a fraction. Pi is a perfect example. Now, while we're here, I want to talk about the difference between rational and irrational. All of these numbers here can all be written as fractions because I can put them over 1. Obviously, a fraction is rational. A mixed number, the square root of 9. The square root of 9 is 3. So that's rational because that can be written as 3 over 1. Any terminating or repeating decimal can all be written as fractions. So they're all rational because this is 1 and 25 hundredths, or 1 and 1/4. This is 1 and 2 thirds. So all of those numbers can be written as fractions, so they are all rational. Irrational numbers. The only thing that is irrational is a decimal that goes on forever and ever and does not repeat. Pi is a perfect example. Another example of irrational is the square root of a non-perfect square. Like, so the square root of 7. That'll be a decimal that'll go on forever and ever and doesn't repeat. Another example of an irrational number would be something like this. 2.479356 ... That shows that it goes on forever and ever and there is no pattern. So that is irrational. Okay, real numbers. Everything we just talked about there are all real numbers. Rational and irrational together form the real numbers. All right. So let's organize these into this diagram. So real numbers, this is going to be, oops, I need to, I can do this. Rational and irrational. At the center, we've got our natural numbers, which are counting. 1, 2, 3. Whole numbers include 0, integers. So all of these are included in the rational numbers. Irrational numbers over here. All right. So negative 12 is rational because I can write that negative 12 over 1. 5/12, obviously rational. Oh, and you know what? We want to be more specific. This is the integers. This is just rational. Negative 4.67, that is a terminating decimal. It is rational. Square root of 5, that is a non-perfect square. Irrational. 0 is rational, so I can write it as 0, 1. It is also a whole number, and it is also an integer. 4 over 1 is rational. It is a natural number, and it is a whole number, and it is an integer. Okay, which subset of the real numbers would most appropriately describe your shoe size? Well, think about it. You could be like an 8, you could be an 8.5. So this would be rational. I wouldn't say integer because if you're a half size, it's just rational. No negative number is less than its absolute value. All right, so let's look at this. I've got, is -5 less than the absolute value of -5? Well, let's remember what absolute value is. Absolute value is the distance that a number is from 0 on the number line. So this is going to be -5 is less than 5, because the absolute value of -5 is 5, because it's 5 units from 0. It says no negative number is less than its absolute value. That's going to be false, because every negative number is going to be less than its absolute value, because a negative is always less than a positive. Think about where they are on the number line. An absolute value is always positive, because it's distance. The difference of two rational numbers is an integer, sometimes, always, or never. Well, let's see. If I did two rational numbers, 7 minus 8 is -1. That's an integer. But what if I did a rational number? I could have 3/4 minus 1/4. Those are both rationals. That's 2/4 or 1/2. That is not an integer. So sometimes. And there's two examples of where it is true sometimes and it is not others. Okay, absolute value of -4 is 4. The absolute value of 27 2/10 is 27 2/10. The absolute value of -1/4 is 1/4, and the absolute value of 0 is 0. Absolute value is the number's distance from 0 on a number line. So it will always be positive. Ordering numbers. Okay, think about a number line. If I am ordering these numbers, which one is closest to 0? Because they're all positive. I'm going least to greatest. Least to greatest. So the smallest number here is 300. Because you're looking one decimal place at a time. These are all 0 for the whole number except this one, so that's obviously the biggest. So this is the smallest, then 3/10, then 33/100, then 3. Now, when you have positives and negatives, think about a number line. The farthest left, further left it is, the smaller it is. So the number on this list that is furthest left is -1/2, then -1/4, then 1/12, and